Okay, guys, we are in Algebra 2, Mod 8. We're continuing our chapter on what's called conic sections. If you remember, Tuesday, we looked at how to draw perfectly round circles. You guys did a great job on that. Most of you got all those correct, centers in the right spot, radius is correct, no problem. Then yesterday, on Wednesday, the 15th, we did ellipses, which were just simply oval shapes and elongated either horizontally or vertically in the shape of an egg or an oval instead of perfectly round. The third type of section we're going to learn how to draw, something you've probably never worked with or even seen before, is a picture called hyperbolas. Today, top left corner of your paper, Thursday 4/16/20, title is, instead of circles or ellipses, it is hyperbolas. And if you look at the four problems we're going to do, minus in the middle, minus in the middle, minus in the middle, minus in the middle. Recognition is half the battle on these. Remember on day one, we had x squared plus y squared equaled r squared. And yesterday we had x squared over a number plus y squared over a number equals 1. So bottom line is, when there was a plus in the middle, it was either a circle or an ellipse. But when there's a minus in the middle, your thought is, oh, this is one of those hyperbolas. So the question, of course, becomes, how do I graph a hyperbola? Okay, guys, stay with me. You gotta think with me here. Don't just copy. Like I always say, think along with me. Get rid of your distractions. Get rid of your phone, your TV, and everything else. And for the next 10 or 12 minutes, focus with me on graphing these correctly, okay? The process is important. Okay, first one. Just like yesterday on ellipses, just a good old x squared and a good old y squared, correct? It doesn't say x minus 2 or y plus 1. There's no numbers attached to the x and the y. So the center of this hyperbola is certainly 0, 0. So just like yesterday, we're going to draw our picture. We got to have a center point to work with. So put a dot on the origin, label it CR for center at 0, 0. Now, just like yesterday when we graphed our ellipses, look, the x squared has a 9 under it, doesn't it? So go to the x-axis, which runs left and right. Go right 3, put a dot, and left 3, and put a dot. Notice I didn't go right 9 and left 9. You are to square root the number that's on the bottom. The square root of 9 is 3. So right 3 and left 3. Now the y squared, of course, the y-axis runs up and down, has a 4 under it, and the square root of 4 is, of course, 2. So I'm going to go up 2 and down 2, put dots. If there was a plus in the middle and this was an ellipse, you would connect those up. We would have our oval shape, and we would be done and move to the next problem. But there's a minus in the middle. It's a hyperbola. What does that look like? Okay, here's what you've got to do. Watch this, guys. Look where my pen is at right now on this dot to the right. Start with your pencil on that dot and go up until you reach the height of that dot and put a dot in that corner. Come back to this dot, look where I'm at, and go down until you reach the height of that other dot and put a dot in the corner. In essence, I'm going to end up drawing a rectangle here because watch, I now go to the left-hand dot and put a dot up in this corner, go to that same dot, and draw a dot in the bottom corner. Oh, I've drawn what looks like a beautiful rectangle, and all you're going to draw is an imaginary line that would be the diagonals of that rectangle. So I draw an imaginary line through the center going through those two corners. And then I draw an imaginary line going right through the center, going through those two corners. Those are actually called asymptotes because they're imaginary lines that are going to be used to guide how wide to draw my picture. So I've got an imaginary diagonal, Another imaginary diagonal, both cutting straight through the center of that picture. And now all you've got to do is draw two curves that look like parabolas that are going in opposite directions. Now, how do you know where to draw them? Okay, listen. If the x squared comes first in your problem, which it does, the x squared is first, isn't it? Then your hyperbola will open left and right along the x-axis. So if the x squared is first, my picture opens to the right and to the left. So guys, you use that dot on the right and draw a parabola opening to the right. Notice it gets close to the imaginary line but doesn't cross it. And then make one going to the left that gets close to the imaginary lines but doesn't touch it. So it's kind of like a satellite dish facing east and a satellite dish facing west. It's two parabolas facing opposite directions, and that's called a hyperbola. Okay, the goal this year is just to get introduced to it, what the standard equation looks like, and how to sketch its basic picture without having a ton of detail or what you would actually use them for. Okay? Go to block 2. Write 4y squared minus 9x squared equals 36. Now, just like yesterday on an ellipse, a hyperbola is in standard form when it's equal to what number? Equal to 1, like this first one was. It's gotta equal 1. Okay? This one's equal to 36. That's not good. We want that 36 to be a 1. So I divide by 36 to get it into standard form. You agree? 36 over 36 gives me the 1 we were looking for. And on that side, guys, some of you aren't very good at cross-canceling. You made some mistakes with that. Look, that's 4 over 36. If you were in 7th grade, 4 over 36 would reduce to what fraction? Wouldn't that be 1 over 9? Because you cancel the 4, and then 4 goes into 36 9 times. So that's y squared over 9 minus, and then you've got 9 over 36 that I'm going to cross-cancel and get x squared over 4. Agreed? Because you cross out the 9, and 9 goes into 36 4 times. So you cross-cancel on the left, and you get this equation that's now written in standard form. So I go to draw my picture. Look, it's good old x squared, right? And good old y squared. There's no numbers attached to them. So once again, the center of this hyperbola is 0, 0. Now careful, the y squared has a 9 under it. Since the y-axis runs up and down, I'm going to go up 3 and down 3. The x squared has a 4 under it, and since the x-axis runs left to right, I'm going to go right 2 and left 2. Again, if there would have been a plus in the middle, I'd connect those up, make my ellipse, and I'd be done, like the easy stuff we did yesterday. Today, it's a hyperbola. So, just like I taught you on the last one, put your pen on that dot, go up and make a corner, go down and make a corner, put your pen on this dot, go up and make a corner, go down and make a corner. And now I can draw a diagonal going through those two corners and a diagonal going through those. And then, okay, freeze. When you go to draw your picture, look at the problem. Which letter is first? Oh, I look out front. The y squared is first, telling me that this hyperbola opens up and down along the y-axis. So since the y squared is first, it opens up and down. Up for one satellite dish, go to this dot, and go down for the other satellite dish. Notice you're supposed to make it as wide as the dotted lines. They get really close to the dotted lines and don't touch them. Okay? Block 3, our third problem. says x plus 2 squared over 6 minus y minus 1 squared over 12 equals, ooh, good news, equals 1. So guys, look, minus in the middle, it's a hyperbola. It's equal to 1, so it's in standard form. When I go to draw this, because I'm ready to draw it already, the key question, of course, remember, is where's the center? Oh, now the bottom numbers have nothing to do with the center of your picture, agreed? That says x plus 2. What's the opposite of plus 2? Oh, negative 2. That says y minus 1. What's the opposite of minus 1? Positive 1. So we now know that the center of this hyperbola is left 2, up 1. And I'm going to put CR right there. Okay, now the numbers on bottom. The x squared has a 6 under it. Guys, remember, that does not tell me to go right 6 and left 6. You don't go right 3 and left 3. You don't cut it in half. You square root the number on the bottom. That is not a perfect square. So I'm getting out my calculator. I'm typing the square root of 6, and I'm getting 2.4. So I'm going to go right 2.4 and left 2.4. The y, which runs up and down, has a 12 under it. The square root of 12 on my calculator is 3.5. So I go back to the center. I'm going to go up 3.5 and down 3.5. And again, your job is to do what? Make a corner, a corner, a corner, and a corner. Your asymptote or your diagonal goes right through the center of your circle. The other diagonal has to go right through the center of your picture. And then remember, all you got to decide, is it a lefty righty or an uppy downy? I look at the original problem. The x is first, right? If the x is first, it opens left and right along the x-axis. So it's a really wide satellite dish facing east and another really wide satellite dish facing west. So I've got two curved shapes facing opposite directions. That's called a hyperbola. And finally, the last one, the second you look at it, again, the minus in the middle tells me, boy, that's a hyperbola. All right. There could be one or two of these conic sections at the end of the ACT test. Now at least you recognize them and can work with them a little bit. There is a number at the end that says 20, and we've said 3 times now, we always want our hyperbola to equal what number? 1. Agreed? First one equaled 1, the second one we got equal to 1, the last one equaled 1. We want this to equal 1, so I'm dividing both sides by 20. On the right, 20 divided by 20 is 1. On the left, guys, this first parenthesis doesn't have a number in front of it, does it? So that'll just stay y minus 2 squared over 20. I'm dividing the whole side by 20. Minus, and then you got a 5 over 20. Doesn't 5 over 20 reduce to 1 over 4? So we've got x squared over 4 for the second fraction. There, it's in standard form. I'm going to draw a picture. Careful, when I say to you, where's the center? I'm going to give you a second to think about that. Most of you would write 2, 0. Guys, remember, there's my x squared, there's my y. My x squared has no number attached to it, does it? So my x value is actually 0. The y has a minus 2 attached to it, so my y coordinate is positive 2. Okay, so careful. I'm going to go right 0 and up 2. There's the center. Since the y has a 20 under it, the square root of 20 is, okay, calculator, Type square root 20, you get 4.5. So I'm actually going to go up 4.5, because it's under the y, isn't it? And then I go down 4.5. The x squared has a 4 under it. The square root of 4, of course, is what? 2. And the x-axis runs left to right. So I'm going to go back to the center. And I'm going to go right 2 and left 2. Again, don't connect and make an ellipse. Because there's a minus, it's a hyperbola. I got to go to this dot, make a corner, getting the hang of it. Make a corner, make a corner, and make a corner. Interesting. I've got a really big diagonal going through there, and another really big diagonal going there. And guys, I got to decide now, is it a lefty righty or an uppy downy? Again, that depends on which letter is first. Since it's y squared first, it opens up and down along the y-axis. So it's going to open down this way. It's not very wide, is it? Because it gets close to the dotted line but doesn't cross it. And then up in that direction for the other half. So it's a satellite dish facing north. The other half faces south. You've got two parabolas facing opposite directions. And again, that's called a hyperbola. Okay? Whew, something you've never seen. Kind of interesting. You can do that. It's not that bad. If for some reason you get confused or mixed up on any of the homework problems, you can always go back to this video and watch any one of these 4 problems over again to try to get the hang of it, okay? Homework for tomorrow. Again, today is Thursday, April 16th. So if you're keeping up with your 20-minute lesson per day, this would be due tomorrow on Friday the 17th by noon. And it's only 4 questions. You got to draw me 4 hyperbolas and email those to me by tomorrow at noon. So you can hit pause here, copy down your 4 homework problems. There they are. 4x squared minus 9y squared equals 36. Y plus 3 squared over 4 minus x minus 1 squared over 10 equals 1. X squared over 12 minus y plus 2 squared over 4 equals 1. And finally, 2 times x plus 1 squared minus y squared equals 8. Okay? Great job, guys. We'll see you tomorrow. We'll graph our last conic section, which is called a parabola. Good job.